I am Angel Rose Munic, and for now we were discussing Calvin's cycle. Last time we discussed light reaction, and as I said, the product of light reaction, which is ATP and NADPH, are used to make sugar in the Calvin cycle. So, how does it happen? Calvin cycle occur within the stroma of chloroplast. It uses the ATP and NADPH to convert carbon dioxide to carbohydrate. Calvin cycle has three phases: the carbon fixation, the reduction, and the regeneration of the carbon dioxide acceptor, or the RUBP. So, let's start with the carbon fixation. An enzyme called rubisco takes carbon dioxide from the air and adds it to a 5-carbon compound called RUBP. This makes a 6-carbon compound that immediately splits and halves to make 2 molecules of 3-phosphoglycerate. In the reduction, ATP provides energy to make an intermediate compound. This reactive intermediate can be reduced or gain electrons and hydrogen. The electrons and hydrogen come from NADPH and are used to reduce the intermediate compound to make glyceraldehyde 3-phosphate or G3P. G3P is the key product of the Calvin cycle that used to make sugar. In the third phase, which is RUBP or the regeneration, 1 G3P is removed from the cycle, but 5 more remain. These 5 G3P molecules get converted back to our starting compound, RUBP. We can make 3 RUBP molecules and 5 G3P. ATP required energy to make it happen. We've completed the Calvin cycle for 3 carbon atoms. Let's go through the process again so that we can make glucose. Photosynthesis equation has 6 carbon dioxides to make 1 glucose molecules with 6 carbons. So always remember that we need 2 G3P to make 1 glucose.